This track unit is another interrelated efficiency step in the operations of the Mt.Newman Permanent Way. It's a continuous action tamper, which maintains track geometry to reduce wheel and rail wear. Working at 3 times the normal rate, the tamper lifts 2 sleepers at a time in its continuous run while pulling the line into position. It was the first unit of its kind in Australia and can cover up to 1.5 kilometres of track every hour. The Newman track's ballast cleaning process is among the best in the world. Dirt borne by wind and water over the 2-decade lifetime of the railroad has tended to break down the strength of the ballast. As the cleaning process proceeds, higher strength ballast brought in from the company's Chichester quarries is being added. Extensive testing is being carried out on new era sleepers that will eventually replace all of the Jarrah wood sleepers of the original track laying. Testing is being carried out on 2 replacement types. There's already 100 kilometres of new sleepers in the track. Concrete and steel units are now being installed with closer spacing than the originals. The new sleepers are designed for the heaviest track use in the world, with axle loadings of 40 tonnes. Near the siding of Bing, the company is manufacturing thousands of concrete sleepers for replacement in the line. Maintenance on the Mt.Newman line is an around-the-clock operation. Day crews carry out the traditional work of gangers in upgrading the track. In the new tradition, these days they have more comfort in the field, with air-conditioned mobile units to transport them to the maintenance locations and to provide a cool refuge at meal times. The community of Redmont, halfway down the line, is the major logistical maintenance crewing centre. Company railroad men and their families live here in a leafy oasis at the foot of the Chichester Range. This is the night operation of the Thermit field welding unit. Replacement of track is carried out in 400-metre lengths, with the sections being flash welded together. A track recording car, loaded with high-technology equipment feeding into a high-speed printout, gives an onboard scan computer analysis of the track sections as they pass below. Any deterioration of the track is easily seen. The information has the added value of helping in long-term track research, with the banks of information showing how various sections cope over the span of the years. All of these track maintenance operations must be blended with the day-to-day running of the big ore trains working the line. The information feeds back into one central traffic control, here at the railway headquarters in Port Hedland. This is the brain centre for all that happens throughout the entire railroad system. The location of every piece of equipment and rolling stock is known exactly at all times, through a combination of track sensing devices and through direct voice contact with the operators and drivers. Radio communication is through 3 VHF channels, relaying to 8 repeaters and 2 terminal stations. This is to be upgraded to a modern digital system over the next few years. The sensors can tell central control immediately of any major happening such as a derailment. But there is also a constant monitoring down to the tiniest detail. Sensors show any undue drag in the rolling stock through faulty equipment. They show wheel temperatures, and infrared recorders send in the message on any axle bearing that is overheating. Hotbox detection of this kind takes into account the related ambient temperature to avoid false alarms that could occur on extremely hot days. Mt.Newman Mining's railroad began with the best equipment money could buy. But in the space of just 20 years, technology has undergone considerable change. Now the company is spending $1 million to upgrade its signalling and sensing equipment.
A couple of years ago, if you'd have travelled down the track and stopped at one of the signal locations, you would have seen a lot of these relays pulsing away, controlling the logic that determines the safe working of the signalling system, the position of trains, and also testing the track's integrity. Now, you'll see one of these modules containing circuit cards like this with microprocessors. The microprocessor electronic cards have led to an improvement in reliability and flexibility of the equipment used on the signalling system. This flexibility and reliability improvement has helped a reduction in signalling delays of 70% over the last 5 years. It's not only in the field that we're making these changes, however. This improvement in flexibility and reliability is also going to take place in the CTC control centre in Headland, where we'll soon be using a mini computer to provide the train controller with the best possible information about what is taking place in the field. Using this information, the traffic controller will be able to make the optimum decision about the running of our trains.
Technical progress is an ongoing part of the Mt.Newman Mining Company's railroad system. It's a marriage of the experience gained in the field through all of the personnel who operate along the permanent way, in the workshops and technical divisions, and through management. Technology is one thing, but in the end, everything really does rely on people. That's what makes it all happen on what is surely one of the great railroads of the world.